Now, of course, we haven't solved this equation. We've just reduced it to this. And what's the point of that?
So that we can solve it easier. We can do. What am I looking for?
It's been a while, so you don't come up with the right terminology, okay?
I can't think of what I'm trying to say here. I can see what I'm doing in my head. Hold on. We can do separation, can't we? Can we separate these?
No, you're not going to be able to separate variables in that one.
No. Okay.
Although it'd be worth trying.
Right.
It's not going to work. Okay?
Okay.
If it was homogeneous, if you didn't have this over here, of course you didn't have this over here, you wouldn't have had a Bernoulli equation in the first place.
Right.
Then you could separate the variables. Okay? And you know, the homogeneous equation of wherever it is. Well, I don't even have the form down here. But if it was this, then it would be homogeneous, right? If this is 0 over here.
If it was a 0.
And then you could separate it. You know, you got the P of t here, you got the y here, and everything separates. You're going to have dy over y equals P of t dt, right? And you just integrate that. Well, this is, and it's worth thinking about that. What this is that would be first order homogeneous. This is first order non-homogeneous. So it's first order non-homogeneous. And you use the integrating factor e to the capital T of t. Okay? So we'll go ahead and do that, but that's just a reminder of the terminology and the solution, okay? And we also just kind of remember that if it was homogeneous, then we could solve it by just, well, the solution, general solution would be e to the negative integral of the P of t function, okay?
Right.
And it's pretty easy to understand why that works. Okay, well, but we solve this, and of course then we have a solution for v. Now we want a solution for y, right? Well, we see that y is 1 over the square root of v, so whatever we get for the solution here, we do 1 over the square root of that, reciprocal square root of the v function, and that gives us our y function. So I could say then, then convert to y, okay? And maybe I'll say here solve for v, obviously, because this is an equation in v, we're going to solve it for v. But we ultimately want to find out what in the heck y is, but there's a simple relationship between y and v.